preparing to live stream.
Yeah, I've just got a message. This is being live streamed. Meeting is now streaming live on YouTube.
What I'll probably do, I'll turn my video off, this one,
Yep.
and I will share. It's where it gets complicated. I'll share a power mirror.
Right, I've now got a message. You are viewing Norman Lockyer Observatory screen.
Oh, I know what I've got to do.
Ah, right, I'm seeing stuff now. We've got 16 viewers, David.
Hang on a sec.
On YouTube.
I think I've got to mute myself, otherwise I get that horrible echo.
Okay.
So, can you still hear me, Dave?
Yes, I can, David.
And have you got a decent image of Jupiter?
Not too bad. I can see the red spot.
Yeah. So I took some videos earlier of it so we can process them and hopefully get a better image.
Okay. Okay. I don't know what it's doing outside at the moment. Oh, but actually, if this is live, then this is we could see something.
So what we plan to do tonight, Dave, you're going to kick off with your talk.
Yep. I'll then
And
give them a 5-minute break, David, to go, or 10 minutes so they can go and make themselves a cup of tea. And then I can either do a sort of virtual planetariums with Stellarium, or if it's clear, we could perhaps do some live streaming.
so you're going, sorry, you were breaking up a bit then. Are you going to do the Stellarium?
Yeah, I can do that, David. Yeah.
Oh, great. Okay. So you do that, and then I'll finish up with some Jupiter images or the moon.
Yeah, that's fine, David.
And if
Yes.
anybody else wants to share images,
Yeah, well, hopefully we'll invite people to send messages via our YouTube channel. Jen can pick them up and hopefully relay them to us, and we can have a look. What I'll do is, David, I'll do me talk, then I'll
yeah,
give people a 10-minute break to go and get themselves a cup of tea and a cup of coffee while I set up Stellarium. And then, as I said, I'll do a Stellarium sort of planetarium show.
yeah.
So if I want to, I've got to share my screen, haven't I? Oh yeah, share screen.
So Janet's just come on board.
Yeah. Oh, actually, David, it's just come up. If I start my share, this will stop the other screen sharing. I will do, but I won't do it at the moment. So
Yeah,
that'll
just let
stop
them
you.
come on. A few more come on,
Yep.
and then say 2 or 3 minutes before you want to start,
Yep.
and then I'll stop sharing.
Yeah. Okay.
I don't know whether it's me or you, Dave, but you're coming over very crackly.
Am I? You sound perfect to me. I don't know, Jen. How do I sound to you? Are you hearing me on the YouTube channel? No, okay. No, so my wife can't hear me. Mm. Mm. Let's have a look. Oh, have I got shared computer sound, haven't I?
Are my comments coming up on YouTube?
According to Jen, no, David. We had how many, Jen? 27? 24 people, and then we're now down to 7.
All right, okay.
Hang on, Jen. You just said. Oh, that's a delay. Whoa. That's a delay. Gosh. Jen, 27. 24 people, and then we're now down to 7. That's a delay, David. Hang on, Jen. You just said. Whoa.
I've been putting messages on YouTube. I can see them on my YouTube feed, but I don't know whether you can.
Let's have a look. The delay is phenomenal, David. I reckon it's a good 10 seconds. Now, there should be messages appearing, Jen. No, Jen's not got no messages, David.
Oh, right, okay. So now I've now lost the feed on YouTube.
Have you got the feed still, Jen?
Oh, it's come back now.
Yeah, we've. Hello, Alan.
Hi there, how you doing?
Yeah. Got the feed still, Jen? Yeah. Blimey, the delay, David, is phenomenal.
Oh, it's come back now.
Right. Yeah, we've.
I've got Zoom on one monitor and YouTube on the other.
So we, and the delay, Alan, is unbelievable. I
Yeah.
reckon 10 to 15 seconds. The delay, David, is phenomenal.
Yeah.
With Jurassic 5, I was meant to be the bee's knees.
No, they're rubbish. I'm impressed with him whatsoever, David. So we, and the delay, Alan, is unbelievable. I reckon 10 to 15 seconds. David, is phenomenal. God.
I think I might switch YouTube off.
Yeah.
Jurassic 5, I was meant to be the bee's knees.
No, they're rubbish. I'm impressed with him whatsoever, David. Oh, blimey.
I know.
Yeah.
Is it me?
No. Well, I don't know. David. Oh, blimey. Oh, but it might have started from the start,
Is
mightn't
it
it?
talking again?
No. Well, I don't know.
People can hear this.
Oh, but it might have started from the start by then.
Yeah.
Yeah, we're gonna have to be careful what we say because our words are going out over YouTube. Oh, but it might have started from the start by then. Yeah, we're gonna have to be careful what we say because our words are going out over YouTube. Is it looping?
I think we've got that echo, Dave.
Yeah, yeah. I'll send Jenny out of the room. We had 24 people, Alan. Then suddenly we lost them all and we're down to 7.
All right.
By the way, David, did you solve the problem of the link dropping to your ASI Air
Yes.
cable?
The cable.
Yeah.
Because I'm currently so that what I've got here, I've got my iPad linked to the ASIL signal, but I've got a cable connected to my iPad to my computer.
Right.
So I've got a stronger signal, of course,
Yeah,
using the ASI's air signal.
Okay.
So it's all a bit complicated, but it's working.
Good.
That's the main thing.
Is the image looking reasonable? Can you see the great red spot?
Yeah, yeah.
Yeah, just about make it out, David.
So I have taken a few recordings, so we can process them later on if you want.
Okay.
I'll do another recording now.
Did you see the pictures, Alan, that we took of the observatory?
I did. Yes.
Yeah. It was absolutely lethal. The car park was a nightmare. It's just solid ice.
Yeah.
Mm.
Yeah. I mean, I don't. I live fairly close to the Holden Hill area that was completely at a standstill last night, but
Right.
didn't actually have any lying snow where I am in Shillingford.
Mm.
But I looked at the forecasts for where I am and Newton Poppleford and Sidmouth, and I
Yeah.
thought late on in the evening it's likely to get a bit chilly. And
Yeah.
in fact, there's yellow warnings of ice and such like. So
That's right. Later tonight. Yeah.
I didn't have an awful lot of compunction about
Yeah.
saying no, I'm not coming.
David,
Yeah,
do you want to give me control of the screen now?
I will. I'm going to stop sharing.
Okay. So I shall now. Hang on. Can I share my I want to share my screen. So
Got the green button.
let's do that. And then let's do no green button. It's not giving me.
Scroll up the top.
Ah, there it is. Yeah, it's all right. Okay, I've got it.
Yeah, you're coming through, Dave.
Okay, oh, what have I done? It's all right. I'll start in a minute. Hang on. I'm getting past a message from my glamorous assistant. The house is on fire. I'm leaving you. Yeah. What we got? Yeah, it's just there is a delay on YouTube.
So I haven't got you appearing on YouTube yet. I've still got my Jupiter image.
Ah, hang on, I've taken mine off for the moment. Ooh. Oh,
Ask
I've now got an
Jen.
interesting nose.
You can see your Jupiter and its moons.
Yeah, that's it. You got it?
Let's do that.
But Jupiter and its moons on Zoom, but not on YouTube.
It's not given.
Hold on, hold on, hold on. Let it catch up.
Ah, there it is. Yeah. It's
Norman
right
Lockyer
down.
Observatory. Yeah, it's there. It's there.
Is that good?
Hold on then. One last cough.
You've muted yourself, Dave.
Sorry about that. I'm just trying to work out how to, so that my picture's up. No, actually, I won't do it. Okay. Right. Hopefully you can all see that. Can you see that?
Yeah, you want to press a little button at the bottom right along your taskbar. You'll see the little like a TV on a stand. If you press that, you'll go to full screen.
Oh, okay. I thought I was on full screen. Let's task says more.
Now, I think that's in your program, not rather in Zoom.
Oh, okay.
On your PowerPoint,
Only PowerPoint, right.
go to slideshow, whatever, start.
Oh, I thought of doing that. I've got full screen here. Let's see what happens.
In your program, not rather in Zoom.
How are you getting it now? You're getting it full screen?
Not yet.
Hold on, Jim.
Slideshow, whatever, start.
Okay.
I thought of doing that. I've got full screen here. Let's see what happens.
Where's full screen?
Yeah, press from current slide.
Yeah.
Or from
How you
beginning.
getting it now? You're getting it full screen.
Not yet.
Hold on, Jim.
Slideshow, whatever, start.
Oh, back. How are we doing? We got it full screen? No? I told Jen. Oh, blimey, what do we do? Well, I've got it full screen.
Well, I don't know about you, Alan, but it's not full screen here. But if you press the from beginning button on your top left, it should go.
Yeah. That's it. Have you got it? Yeah. Now I've got some little buttons at the bottom here. One is settings, screen.
Well, I should go like that, Dave. I mean, we can still see the screen, but we've got all your little small icon images on the left.
Yeah.
You can still see it.
Why can't I? Let's have let's have one more look. Is it something I've done? Right, let's have a view. Gallery view. Altitude. Oh, live on YouTube. I don't want that. Right, speaker view. Okay. Right, screen sharing.
Dave, I just thought, do you have to go live on YouTube as well?
Ah, do you want me to click?
You probably have to.
Okay, what? Host live on YouTube. It's screen sharing, but when I preview, no. Okay.
That's it up now, Dave. You're muted. Dave, you are muted.
We had it. We had your screen up full. We can't hear you. You're muted.
New share. Entire screen.
We had your screen up full.
Yeah.
But there was a notice that said your microphone is disabled when sharing computer audio, which presumably refers to you.
Right. Hopefully you've got it now.
Not yet.
No.
Right. Let's go up. Beginning. Right. We've got Alan. Got me. Oh, you are live on YouTube, but the SharePoint toolbar you have used presenter view. Oh, okay. So hold on. So the on YouTube, but the SharePoint toolbar. I haven't got presenter view.
It says on the top. It says we're live on YouTube.
Yeah.
I don't know how we access the SharePoint toolbar.
Yeah, this is it.
Zoom.
Hang on. No. All right. We'll just have to go with it as it is. As is.
Yeah, we haven't got your PowerPoint up now, Dave.
Yeah, I'll give it a minute, David. It's coming. Hmm. Not there. I had it. Right. What am I doing wrong?
You're sharing a screen.
Right. Okay. So you should be able to see it. Right. I'm going to do speaker view. I don't want them all right. Share screen. Right. I'm going to share the entire screen. Edge tab. Window. Right. Now I've got this. Don't want that.
I've got a picture of Sir Norman up now.
Yeah. Okay. Here we go. We're getting close.
Are you on dive?
Here we go. Come on. Come on. Is it come up yet? Come on. Well, what's going on?
I'm going to close a lot of my windows.
Okay, well, we had it. I don't know what I've done. You haven't got it, I take it.
Not yet. We just got a picture of Norman on the screen.
Yeah, well, it should go to my presentation straight after that.
So YouTube's just closed down then, has it? Well, it's closed down on my screen anyway.
I've done something wrong. I'm sorry. I don't know what I've done. Right. How's that?
Still got just Sir Norman Lockyer photograph on the front.
All
But
right. Let's
no
start
sign of
again.
your PowerPoint, Tom.
Let's try that. No. Start again. You are screen sharing. Right. I do. Right. Okay, that's it. That's what I want.
Let's come back. That's good.
Right, well, I've clicked on share entire screen, and I'm just waiting for it to come up now. The site will be able to see the contents of your screen. But it's not doing it. No, it's not. It's just me, isn't it? This is painful, Jen. How do I stop this? Oh,
Are we still showing anything on YouTube?
Yeah, that's coming up okay. The picture
yeah.
of Jupiter.
Oh,
Well, we're still showing Jupiter.
Yeah.
Well, that must be wrong because I've stopped.
yes, and I'm getting.
So that shouldn't be coming up.
Jen's getting. Oh, Alan. She's got Alan now.
Oh right. My YouTube had stopped for a while. I've restarted it again. I think I'm running behind time on it. Where am I? Well, hang about. Ah, right. I was running, but it was running again from the beginning on mine. So it's it seems to have sort of come out of.
What do you?
I'm going to YouTube.
It gets to the end of the picture of Jupiter, and then just says Norman Lockyer Observatory, and stops there.
A message from Tony on YouTube. I see Alan at the moment.
Yeah, that's right. Yes, we're seeing Alan.
Oh right, I'm not seeing me. I'm not-
Yeah. I can't share anything. The share button is highlighted, but it just doesn't.
So when you press
Oh.
the share button, Dave, what do you get?
Right, well, I've just pressed it, and after about 25 seconds, you should see Sir Norman Lockyer.
So I've got an option here. Multiple participants can share simultaneously. I'm going to click that box.
Okay.
Has that made a difference?
Somebody's just come back and said if Alan mutes, the video will not flick over to him. Right, let's have a look. Share screen. Ah, that's better.
Okay, I got Sir Norman again.
Okay, so right, let's go.
Yep, I got Jupiter and its moons.
Right, you got it?
It's full
Yeah.
screen, Dave. You're there.
Yeah, have you got it full screen?
Yes, we have.
Excellent. Right, we're going. Hang on, no, you've got to mute, Jen, apparently. Yeah. Okay, good evening, everybody. Whoa. Well, that was exciting, wasn't it? God, that's 30 minutes of our lives we'll never get back, but sorry about that. Welcome to tonight's presentation. Sorry it's not live at the observatory. There are pictures circulating. Conditions up there were very, very unsafe, and bearing in mind there's a big hill to get up to, and it means getting down afterwards. We decided that we would try and live stream tonight's presentation and give you a live showing as well of the planets. Okay, so a few domestics, and this obviously slide was designed for people who were there sitting in the room with me. So fire alarms. Well, if you hear a fire alarm in your house, get out quick. You should know where your toilets are. As for this evening, well, as I've just said, you are going to get a talk from me, Unlucky, about Jupiter. There will then be a 10-minute break for you to go and take Valium and whatever else you need to get through the rest of the evening. And then there'll be a virtual planetarium show. And then what we hope to do for you all is to do some live streaming of the planets, particularly Jupiter and hopefully Mars, and possibly the moon. David has kindly taken some videos earlier in the evening, which he will stack, and he will process these images so that if we can't see the planets live, at least we will see images that were taken an hour or two ago. Okay, let's just have a drink of gin. Right. So, okay, so I'm conscious that Janet Downing's on the video, the call tonight. So I'll leave much of Jupiter the myth till the next time we see Janet. Janet, Jupiter is the Roman god of thunder, and he is the contemporary of Zeus. He was seen as a protecting and moralizing deity, and he is strongly associated with oaths, treaties, and leagues. I'm not sure what leagues. Well, I did mean to look it up, but it all got a bit hectic today. In the presence of a priest or one of his priests, a marriage was considered most sacred. But Jupiter, the facts. Jupiter is the 5th planet from the sun. It's the largest planet in our solar system. Interestingly, it has a rotation of 9 hours and 55 minutes, which is very interesting because you tend to find that there are certain types of astronomers, I'm not one, who during this time of year can watch the entire rotation of Jupiter in one night. You can see, yeah, it's dark enough and long enough that you can see an entire rotation. And some people using clever software have actually made an image of the entire rotation. Jupiter takes 12 years to complete one orbit of the sun. And as of 2023, it has 95 known moons. Diameter of Jupiter is the equatorial diameter, obviously, is 88,900 miles, and its distance from the sun is 483 million miles. At its closest approach to the Earth, it's generally 365 million miles, and its furthest distance from the Earth is generally 601 million miles. Interestingly, Jupiter, it is the largest planet in the solar system. If it was a little bigger, 108 times bigger than it is now, we would have a second sun in the sky. 108 times is not many in astronomical terms. Jupiter's atmosphere, as you will see tonight, is comprised of belts, bands. This is a readily downloadable chart on the right here of the Jupiter's cloud features. And if you notice, you've got south at the top, north at the bottom. This is a representation of what you would see generally through standard telescope, and these are the various zones that you will see depending on the size of your telescope. There is plenty of websites that observe these bands, these cloud features. You are invited through them to download charts and enter data onto these charts, which you can then upload and which they use to map the patterns, the weather systems and the storms on Jupiter. The atmosphere primarily is composed of hydrogen and helium. Does contain small amounts of water, ammonia and methane. It is believed to have a solid core of rock and ice, but there is some sort of challenge to this now with recent space probes. The atmosphere is comprised of 4 layers: the troposphere, the stratosphere, the thermosphere and the exosphere. Interestingly, here on Earth we have 5 layers. Jupiter is missing a 5th layer, the mesosphere. Right. Okay, the great red spot tonight, which if you logged on a little bit earlier, you would have seen in our test transmissions, that you would have seen that the red spot was just about visible. It is an elliptical shaped anticyclone that rotates 1 full rotation every 4.5 days. As you can see, it is mentioned, measures 10,160 miles across, and it's large enough to swallow the Earth and a little bit more. It was first observed in 1830, but there are possible sightings of it going as far back as 1664. The spot has changed. It does change since 1830, and it is getting smaller. Since 2012, the rate of this shrinkage has increased. It's not known how the spot gets its color, and it does change. It has been white. To me personally, it looks more like a ruddy brown than a red, but I have seen it a striking red color. So yes, so the color does change, but we're not certain what the cause of this is, of the red spot, other than it's a storm. Jupiter has a powerful magnetic field. This magnetic field is the largest object in the solar system, and is thought to be generated from metallic hydrogen at its core, which is spinning rather rapidly. The magnetic field reaches a vast distance out of space. It encompasses all of its moons, and nearly reaches Saturn, the orbit of Saturn. In 1955, it was discovered to be a source of radio waves. These radio waves were recorded at a frequency of 22 megahertz. On occasions, a radio outburst from Jupiter can make it the brightest radio source in the sky, apart from the sun. I mean, be careful here. I'm not talking about a visual observations, but if you were looking on a radio telescope, you would certainly see that it would be one of the largest radio sources in the sky at that moment. Interestingly, this then led scientists to speculate that Jupiter had a magnetic field, which was confirmed by the early space probes, the Voyager and the Pioneer probes. Now, this is another interesting moment in the history of Jupiter. Jupiter, being the size that it is, does have a powerful magnetic field, gravitational field, sorry. This gravitational field has been known to disrupt objects, mainly comets, that have come too close to it. What's happened is, as they've approached, they've interacted with the gravity of Jupiter. This has altered their orbit. And effectively what it could mean is that a periodic comet, a comet that returns regularly over a period of 10, 20, or even 76 years, suddenly its orbit will be altered to such an extent that it will leave the solar system, sometimes never to be seen again. So we knew this happened. We knew that this was going on, that Jupiter was affecting all sorts of objects, asteroids, comets. But interestingly, this was the first time that this event was ever seen, observed anywhere in the solar system. Evidence has been found of impacts, not recent, but on July 9th, well, a comet Shoemaker-Levy was observed. It was observed entering the solar system. It broke apart in July 1992. These components then impacted into Jupiter on July 1994. So this was the first time that we had direct observation of an impact into a body in our solar system, Jupiter. We'd seen evidence of it. We've got evidence of it on the Earth, but this is ancient craters. This was live. This was happening, and I believe it was observed by astronomers at the Lockyer Observatory. The impact of the comet's fragments were visible for months afterwards, and I hope that you can see this picture of Jupiter. You can see these nasty black marks. This is where fragments of the comet impacted and hit Jupiter. The seventh fragment of the comet, and the largest and the brightest of the impacts, and I think it's this one to the top right, so that would be, what, about 3 o'clock on the image, you can see it. That was the largest fragment of this comet, and it was the equivalent, amazingly, of us setting off all our nuclear weapons at once. The explosion was that thing. And these fragments, these dents, these black marks, these disruptions in the atmosphere were then observed for astronomers for several months to come afterwards. Sorry, excuse me. Okay, so what about images that we can take ourselves through telescopes using conventional equipment? These are some of the images that were taken by members here, mainly by David Strange. The top left image is interesting because if you look at around about 2 o'clock on the thing, you'll see a black dot. This is a transit of one of the Jupiter's moons. This happens quite often. It's an interesting spectacle, but there's a serious side to it, because these things are recorded, the time taken, how long it takes to transit the body, and this gives us various information on what's happening. So this is actually a transit of one of Jupiter's moons, and effectively what's happening is it's the moon is going across Jupiter and it's casting a shadow. Nice one here on the right of the red spot, and if you look to the left you will see a white flash. That could be another impact of a minor body, not on the scale of the comet of Shoemaker-Levy. But again, you see these regularly happen, these transits, these impacts, these sort of flashes. They are rare but not uncommon. So, okay, so Jupiter has it has 92 moons as of 2023. But Jupiter has 4 moons that we call the Galilean moons. This is because they were first seen by Galileo when he turned his telescope towards Jupiter in 1610. These were the first moons ever discovered by a telescope. We can still see them. You can see them through binoculars, through a pair of 10 by 50 binoculars. If you've got young children, it's great fun just watching how these moons move about and dance about Jupiter. If you want a little project for your children, just go out at the same time every night, just map the moons where they are. Excuse me, sorry. So map the moons where they are. You can use, there's various software programs. There's a piece of software called WinJupos or Stellarium, and these will tell you what positions of where the moons are. So what you're looking at in the order that you're looking at. There are magazines like Sky at Night magazine and Astronomy Now. Again, they will give you tables telling you where the moons are and when they're going to be transits. There was only one other moon discovered by telescope. That was Amalthea. That was discovered by E. Barnard in 1892. All the other 90 odd moons have all been discovered by space probes and by photography. Barnard's was discovered by photography, and it was quite amazing, really, because effectively Amalthea was just basically a captive piece of rock from the asteroid belt. Aside from the 4 main moons, most of the moons of Jupiter, the other 84, 85 odd, are all effectively captured objects, asteroids from the asteroid belt, or just wandering around our solar system. So of the 4 main moons, the Galilean moons, we have Io, which is 421,000 kilometers from Jupiter and has a period of 1.77 days. Interestingly, this body is volcanically the most active body volcanically in the solar system, has over 300 volcanoes. It was speculated that over a period of about 2 to 3 million years, Io actually turned itself inside out because it was continually spilling lava onto its surface and then collapsing in on itself. We know that this activity is caused by something called tidal flexing. Tidal flexing is not uncommon. However, in this case, because of its closeness to its parent body, Jupiter, and because of Jupiter's gravity, Jupiter is continually pulling at the core and stretching the surface. And as you can see there, it stretches the surface of objects. It stretches the surface by up to or just over 100 meters. And this naturally causes friction, and obviously friction, you get heat. So this is what's happening to poor old Io. Ganymede, distance from Jupiter, 1 million kilometers, orbital period 7.16 days. This is the biggest moon in the solar system, and it's larger than the planet Mercury. Also, this moon has unusually a magnetic field. It has a low density, comprises 50% water and 50% rock. And the source of this magnetic field may be due to convection at its core. So this is currents flowing, and in flowing in doing so, generating this magnetic field. There are features on the surface, and interestingly, space probes have observed over a period of time, they've taken pictures, they have observed features moving. So they'll take a picture of a rock formation, and then they've noticed that 2 or 3 years later, that rock formation has moved. So there is movement on the surface, which is indicating that there is water ice there. And then we come to Callisto. Callisto orbits 16.69 days. Its radius is 2,400 kilometers. As you can see there, though, this is the most heavily cratered object in the solar system. But what we are looking at, what you are looking at, is a very, very, very ancient features, a surface. Effectively, nothing is happening on this moon. Nothing. There's no plate tectonics. There's no volcanism. There's no processes going under the surface. So literally nothing is happening to erode, to wear down, to affect the surface. So you are seeing the surface around about 2 to 3 billion years ago, when this object was hit by a large number of asteroids, rocks, and that those craters have not been eroded away by any features. But there is the possibility of an ocean, and then underneath its surface. But again, because of there's no processes like plate tectonics, and an analysis of the probes that have imaged it, the possibility of life in this ocean on this moon is very, very small indeed. As a result, NASA, their next probe, which I will talk about later, will be focusing more on Europa than Callisto. Interestingly, it does have a thin atmosphere made up of carbon dioxide and oxygen. And this is the prize. This is the prize that NASA are going after. Its orbital period is 3.55 days. Its radius is 1,560 kilometers. But Europa is a rocky object. It is covered in ice, and this ice is well patterned. It's known to have a really iron-rich core covered in a massive 150 kilometers of ice. It has a magnetic field. It has its own magnetic field, but this magnetic field is also interacting with Jupiter's massive magnetic field. And as a result of this interaction, scientists believe that the ocean may be liquid under the ice, or there may be a liquid ocean under the ice. It has a very, very tenuous atmosphere, which contains amazingly oxygen, water, and hydrogen. Okay, so there have been space missions that have flown past Jupiter. We had Pioneer 10 in March the 3rd, 1972, and Pioneer 11 on 6th of April, 1973. These probes, first launched, proved an amazing success, sent back some amazing pictures of Jupiter, but also planets in our solar system. Effectively, they were sort of exploring the solar system. One of the probes is now left our solar system and is now heading towards the Pleiades, and it's hoped that it will reach there in around 45,000 years time. Voyager 1 and Voyager 2, interestingly, Voyager 2 was launched before Voyager 1. It was due to a couple of technical issues which delayed Voyager 1. Again, these probes did tours of the solar system and greatly increased our understanding of what was going on. And as you're probably all aware, they carry the gold discs with music, pictures and images of mankind and maps of where we are. So they're now gradually leaving our solar system out into deep space. The two most important missions was the Juno mission, which entered orbit on the 4th of July, designed with instruments to penetrate the clouds deep into Jupiter and get to the heart of its core, and also to study the moon. The mission is due to end in September 2025, when the probe will be deliberately sent into the atmosphere, ultimately to burn up, but there will be instruments recording what's going on and hopefully transmitting information back to NASA. It has discovered that one of its discoveries is that Jupiter does not have a small solid core, but has a large, fuzzy, messy core. And also it's discovered a zone of great blue spots that go deep, very deep into the atmosphere. Although actually how these are formed, how these are caused, we do not fully understand yet. And the main mission now, which took off on the 14th of October 2024, is the Europa Clipper mission, which is scheduled to reach Europa in April 2030. It will carry out 49 flybys of Europa, and eventually it is looking for a potential body of water below the surface, and also is looking at the chemical composition of this water to see if it could support life. The plan is to launch a more ambitious mission to Europa, depending on the results of the Europa Clipper. And I think the plan is to land a probe onto Europa and carry out tests, drilling to see what's below the surface and to see what's going on, to see if this water is capable of supporting life. And this is a NASA image. So effectively you see here the Earth is 12,742 kilometers in diameter. Our ocean has a depth of 4 kilometers on average, and is expected to contain 1.4 billion kilometers cubed of water. But if you look at Europa's diameter is only 3,120 kilometers, but its ocean depth is believed to be 100 kilometers in deep, and its volume is 3 billion kilometers cubed, believed. So you can see just underneath, 29% land, 71% water for the Earth. Europa is covered in a global ice crust, 3 to 30 kilometers thick. Okay, where is Jupiter? Well, you can't miss it at the moment. If you can find Orion, you can find Taurus, you'll see the bright star Jupiter, just close to the Hyades and close to Aldebaran. Don't confuse looking due south at the moment. We are seeing Venus. That is the bright star soon after sunset. And again, if you've got a pair of binoculars, well worth having a look at Venus while you're looking at Jupiter. These are some images that were taken on the left. That was taken with the sort of thing that you can expect to see through a 3-inch refractor or a 6 to 8-inch reflector. Through a smaller telescope on the right, the image on the right, you will just see a bright disk. You won't see any detail, particularly through 10 by 50 binoculars. But if you look here, 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 and here, you can see the 4 main Galilean moons. And if you want to remember what their names is, just remember the saying, "I eat greens constantly." Io, Europa, Ganymede, Callisto. So I hope you can see those. But yes, certainly is a nice little project if you want to just sit out in the evening, get out there with the children, quickly just make a little sketch of the moons, and then do that night after night if it's clear. And you'll see these moons will dance around the moon. Some will disappear behind Jupiter. And that's the end of part 1. Thank you very much.
Many thanks, Dave. That was great. You came over loud and clear, and all your pictures were transmitted
Good.
fine. So thank you.
Right. So what we'll do now, if you're agreeable, David, 10 minutes for people to go and have a cup of tea.
Yep.
And then I'll take people through Stellarium.
Yep. So we start again at 8:30, 23rd.
Yeah, that'd be great. Okay.
So
look. How are we doing, David?
Yeah, we're all fine. You're good to go, Dave. I can see your screen. You've got Stellarium up.
Okay. Okay, everybody. Okay, so the second part of the evening. I've just looked out the window, by the way, and I'm sorry to report that it's cloudy. But hopefully David's got some images to show you later. Okay, so tonight, this is a sort of a little bit perverse, but I'm hoping you can see this. If you've got a camera, and you've got clear skies, then you will see in the run up to midnight, you will see an 81% lit moon approaching the Pleiades open cluster. It will pass close to some other more as interesting open clusters in the next few hours, early hours of January the 10th. Okay, on the 10th, we have Venus. Again, well worth having a look through a small telescope or a pair of binoculars. It reaches greatest elongation tonight, and it will be 50% phase. So 50% of it will be lit, 50% of it will be darkness. After tomorrow night, Venus will start to appear as a crescent. Perversely, when it does appear as a crescent, it tends to appear larger, even though it's fainter. And if you look, Venus is a nice line with Saturn and with Neptune. So yes, well worth looking out for that tomorrow night, the observatory night, but no doubt it will probably be cloudy. Not that I'm negative. Right. We're back to our friend Jupiter. On Monday the 13th, there is an opportunity so on Monday there will be an opportunity to see the shadow of Ganymede pass over across the face of Jupiter. The transit starts at 15:01 or 1 minute past 3 and will finish until 26 minutes past 5. Its shadow should be seen between 6:30 and 9 o'clock. So that's on Monday the 13th. On Tuesday the 14th, in the early hours, Mars will sit is that right? So Mars will be close. Oh, there's Mars. So Mars will be close to the full moon. Mars will be shining at -1.4. The moon Callisto will be 3 seconds arc seconds from Jupiter's northern post at northern pole. Sorry, at 1720. On 16th of January, Mars will be at opposition, so it'll be at its closest point to the Earth. So it'll be a good time to get out and get some images. If you're on our WhatsApp group, you'll see that David has been sending out some rather superb pictures at the moment of Mars. On the 18th, we have an interesting spectacle where Venus will be very close to Saturn. Hold on, let's get the time right. So yes, so on Saturday the 18th, early in the evening, look southwest, and you will see Venus and Saturn very close together. On Monday, Ganymede puts on another display, transiting the planet Jupiter 6:30 until 8:50. Its shadow will follow later, transiting the disk at 10:30 until 1:20. Yes, okay. On Thursday the 23rd, the moon of Callisto again sits 3 arc seconds from Jupiter's southern pole this morning. If you've got a telescope, Titan will also cast a shadow on Saturn between 1528 and 2100. On Saturday the 25th, the moon's libration, this is its rocking motion, will favor the western limb, giving the moon orientalis when you can find the moon. Oh, and it's below the thing. So I'm sure Alan Smith will be out there looking for the moon and looking at its libration and looking for this crater, or no, for the sea. On Monday the 27th, again, Ganymede will transit another transit event crossing Jupiter between 2000 and 0034. On Tuesday, the moon will be out the way, so that'll be great time for me and Hugh to open up the observatory if it's clear. So it's a good time to get your binoculars out, get your small telescopes out, and start looking at Orion's belt. This is one of my favourite parts of the night sky, and it's got something for everybody. It really has. Whether you've got binoculars or a small telescope or a powerful telescope, or especially if you're using a sea star, yeah, there are some great many objects to enjoy in Jupiter, in Orion. Best to you can use Stellarium to find these objects. 37 clusters, a nice binocular object, and it's best viewed at through binoculars because it looks like the number 37. If you tend to use big telescopes or moderate sized telescopes, they bring out a lot more of the stars in the background stars, and these tend to drown out the asterism that you can see, and that's why sometimes some of these objects are better seen through small telescopes or binoculars. On Friday the 31st, there's a challenge for all you astronomers who like observing the planets in daylight, because at 1:22 there's a challenging partial eclipse of Saturn by Titan. It will occult the northern limb of Saturn. While partially occulted, Titan will enter Saturn's shadow at 14:33, appearing at 7:43, but this will be at a low altitude. And that concludes a rather quick whip through what you can expect to see in the night sky in the coming days. Thank you.
Many thanks, Dave. That's great.
Right.
So, would you like me to take over now?
Yes, Dave, if you want to. David, sorry.
Unfortunately, the sky has gone really hazy, but what I will do, I will share my screen. Can you all see a rather hazy picture of the northern limb of the moon?
No, David, I think it's just off screen. Or it needs focusing.
Can you see my screen which says Moon Go Video?
Ah, right. I'm starting to see some detail.
Okay, as long as you've got something up there. But what I will do is, because it's such a hazy sky, let me just point out what we've got here. Well, this is the crater Plato, and this is the Mare Frigoris, the Sea of Cold, and up here is the Mare Imbrium. But obviously, it's not the ideal conditions for imaging the moon right now. So what I will do, I will close that down, and I'll show you some pictures we took earlier. So let's see what we've got here. Can you see that? So what we've got here is crater Plato, the lunar Apennines with this little rift here, the great Alpine Valley here. This is Mare Imbrium. This is a huge volcano caused by a giant impact on the moon. These little blobs here are actually mountain peaks, and Pico. This is the famous Sinus Iridum, the Bay of Rainbows. That would be equivalent to probably Lyme Bay extending right down to Cornwall. So there's quite a large feature on the moon here. If we go to another shot. This will be at the, of course, you get an inverted image in the telescopes. This will be the southern uplands part of the moon. This was earlier this evening. And here we've got the very bright ray crater Tycho. When the moon becomes full in a few days' time, you'll see lots of rays emanating out from this crater. This is a more recent impact. Probably happened about 50 million years ago. And although that crater is quite big, it was probably only caused by a rock not much more than about 50 meters in diameter. Above Tycho here, we've got the famous large crater Clavius, with its lovely chain of little craters getting smaller, running across it. Right, so let me show you some images of Jupiter we've got earlier this evening. Here's a great red spot. This was the last image I got of it just before Dave's talk. You can see the great red spot right on the limb there. What we take about between 30 and 60-second video shots, and we stack them all together and we'll get a sharper image. I'll demonstrate that in a minute. Here's another shot that's not quite so bright. And here we have the great red spot, just literally this about half an hour earlier than the previous one. So you can see it's sitting right on what we call Jupiter's meridian. Jupiter's meridian will be at the equivalent of our 0 longitude as you go through Greenwich, of course. And we measure all the what we call the transits of these features, the time that they transit across the central meridian of Jupiter. You can see here the seeing conditions weren't all that ideal. The image is jumping around a lot, but you can see quite clearly the north and the south equatorial belt. And that was probably around about 6 o'clock this evening when the great red spot was just appearing on the limb. So Jupiter rotates very quickly. You can just see in a matter of an hour or two, the great red spot has transited right across Jupiter. So other planets, of course, up there tonight, unfortunately it's cloudy, we can't see it, is a wonderful red planet Mars. Mars actually reaches opposition on January the 16th, so that will be at its brightest and nearest to the Earth. And what you can see here, we can see the north polar cap of Mars here, this little ice composed of ice and carbon dioxide. Got a dark feature here, this is the famous Mare Acidalium, and Mare Erythraeum, the stark feature at the top. Right, so what I will do now, we will stop sharing that. And I'll go into another little astronomy program called, if I can find it. Hang see. Should be here. Let's just. And for some reason, it doesn't. Oh, here we go. Right at the bottom there. Right, folks, can you see a picture of Jupiter top left?
Yes, I can.
Great, okay. So what we've got here, we've got this little program called AstroStack. Now, I showed you earlier that little video we had of Jupiter. We can zoom in a bit bigger, make it a bit bigger. And we can play this video. So I hope you can see a Jupiter dancing around with a great red spot round about here. Okay, so we'll stop that. And what we're going to do, you can see this is about 2,500 image frames that make up that. And we're going to register them all together. So I'll press the register button. And we are, number one here, we're going to press detect the planet or disk. And it's made a little green box around it. So long as the planet stays inside the outermost box, we can adjust the size of that if we need to, but we'll leave it at 50. We're going to press the algorithm C, which is a disk or surface with details. Now we're going to analyze all those 2,200 frames. So now it's analysed them. We've got the sharpest frames at this end and the poorest frames at this end. But what we can do, we can tell the software, we just want perhaps the first, we'll make it 30% of the best frames will be up here. So we press OK. And now we're going to put on a lot of what we call multi-points. These are little 48 pixel diameter little squares you can see that have been aligned all over the image. And what we're going to do now is we're going to save it as a TIFF file, and we're going to stack all the best 30 of those images in that video sequence. So we're going to press stack. And off we go. Press edit. We can close that now. We can close that. We're going to zoom in a bit more, make it a bit bigger. I hope you can all see that. And now this is where the magic happens. We press a little tab called wavelets. It opens up another window. We're going to set the noise pre-filter to about half a pixel. And if we use the wavelets high frequency slider, this one here, you can see as I press it, we get a sharper picture.
Mm.
If I press too much, you can see it will overcook it.
Mm.
So we don't need to go that far. We take it right back. We can also adjust the strength on this bottom here. So it's just a question of playing around with this until you get a reasonably sharp image. We'll leave it like that. And then we can look at the low frequency wavelets. This will appear to offer more contrast, particularly the darker belts. Then finally, we've got reduce a noise filter. This will reduce what we call the background noise, a little fuzzy detail which is in the background. But again, you can overcook that. If I turn that right up, you can see what happens. It smears out all the detail. So we hold that to about there. and we say OK. Now, the next thing we want to do is look at the white balance. You can see there's quite a bit of blue in that picture. I did actually use what's called an Antlia tri-band filter on it. So that was imaging both red, green and blue. But this will make it look a bit more natural looking. We can adjust the brightness, something like that. And then we can adjust the levels to what looks reasonably. So that's probably a bit too much contrast there, but it shows the great red spot quite nicely. It's sitting in this hollow called the red spot hollow, and you're beginning to pick up some nice blue festoons in the equatorial region. And then, of course, then we can save that. As a TIFF or as a JPEG. So that's basically how we process planetary images using a simple little program called AstroSurface. There are other different types called Registax and AutoStackert, but the beauty of this little one is it does the operations of both selecting the best images and stacking them and sharpening them as in one program. So, Dave,
Yeah.
anything else you'd like me to add?
No. What about doing the Mars picture?
We do the Mars picture, yeah, okay.
Yeah.
Let's file, open file.
Is this freeware, this AstroSurface?
Yes, it is.
Oh,
So let me see. I've got some Mars pictures. Let's find a decent Mars picture. This looks all right. This is Mars on the 6th of January. So, of course, Mars is a lot smaller than Jupiter. So here's a piece of monochrome. We're going to zoom in a bit. We press the bare RG, and you get a color image of it. If we play it, you'll see again we're suffering with atmospheric disturbance. The planet is jumping around. But what you can see is the south polar cap of Mars here. So we'll stop that. And we'll press register button. We press detect. And again, it's put a little green box around it. We select the algorithm C for disk or surfaces, and we press the analyze button. Again, it's come up with our quality graph. So similarly, we'll probably choose the best. We'll go 30% of the images. Right about there. Press OK. Multi-points. Again, use 48 pixel size. Press set button. Output will be as a TIFF. And press the stack button. So there we go. Go edit. Close it. Yes. Close that down. Zoom in a bit more. Go to wavelets. Turn the pre-filter up a bit. Select wavelets. And you can see some nice bit of detail coming in
Mm.
now on the surface of Mars. We use low frequency, it's a little bit darker. Reduce the noise a bit. Right, so something like that. Perhaps reduce the strength a bit. Okay. Go to white balance. Actually, it made Mars look less red.
Mm. Is that the atmosphere we're seeing lower right, David?
This is what we call the rinding around the rim of Mars. This is imaging artifacts. So
Oh,
you
okay.
pop this bit out. The bright
Mm.
bit here, this might well be clouds on the limb of Mars. This region here is the fastest volcanic region. So lots of giant volcanoes here, and they clouds gather on the mountaintops of these volcanoes. This feature here is the Sinus Abaeus. Polar cap here, this is a Marietta Dalium. And just coming into view here will be the famous Eye of Mars, you might have heard of the Valles Marineris, the
Oh, right.
huge
Yeah.
Martian canyon just coming into view here.
Mm.
Around the top here, you've got some orographic clouds around the South Polar region.
Would these images have been taken with your richly Crichton 10-inch?
That's right, yes, yeah.
Yeah. And which camera did you use, David? The 533?
The ASI 533,
Yeah.
the one that's on the camera telescope at the moment.
Yeah.
Just looking, let's do another quick shot of the moon. We might have the moon back. Hang on, let's put a video on. Yeah, we've got the moon back, so I'm going to just play about with the settings a while. Right, I'm going to stop sharing that, and I'm going to share. Can you now see the moon?
Yes.
Right, we'll give you a very quick tour of the moon. Oops. Right, what we've got here, of course, is the big dark crater Plato, and running off to the left is the lunar Alps, and with the Great Alpine Valley cutting across here. Let's move that across. On the other side, we've got these little solitary mountain peaks. And over here, we've got the one, Mare Imbrium. Put that out of the way. Actually, we need to.
David, can I just say something? We've got people on YouTube. If you'd like to ask a question, you've got a live chat option. Please feel free to ask a question on the live chat, and we'll pick it up, and I'll bring it up and ask David your question. Thanks,
Okay,
David.
thanks, Dave. So what we've got here is this wonderful sinus iridum. This feature is probably as large, if you imagine Lyme Bay going right down to Cornwall. And you actually see little ripples of lava. When this was all flooded, the molten lava actually sort of flew over this crater rim and flooded that whole crater. So this crater is obviously older than the Mare Imbrium, the big impact that caused this huge lake of lava. What I'm going to do now is if I go the right way. So the other side of the Mare Imbrium is this wonderful the lunar Apennines, this mountain range that rims Mare Imbrium. And round about here, not really that clear, but was the landing of the Apollo 15 spacecraft near Hadley Rill. On very good seeing conditions, you can actually see a little dark rivulet running through here. And that's where they tried out their first lunar buggy. And lots of pictures of Mount Hadley from Hadley Base there. Coming on further round, on the tip of the Apennines is this feature here, which is Crater Aristophanes. And going further on round, well, let's just move it down a bit. Is the huge rayed crater Copernicus. Let's put him in the center. Copernicus with his two little mountain, and you can see the rimmed ramparted walls of Copernicus. Whoop, going wrong way. Oops. One of the craters, a very large crater here just coming into view now, is crater Clavius, with this little chain of craters getting smaller. And just above it, or I should say below it, if I can zoom out, is crater Tycho. There's crater Tycho with its peak. The moon's actually getting quite bright, so I'm going to shut down the gain. So that's a slightly wider field of view. Again, we can zoom in. So there's a closer look at Tycho. So, I mean, that crater was probably only resulted from an impact of something about 50 meters in size. You don't need a very large rock to cause a big hole on the moon. Of course, the moon has no atmosphere, so any rock traveling at many thousands of miles per hour has a lot of momentum that will make a big hole in the moon. Let's have a look at some other features. Let's move up. Now, one of the features on the moon are these crater chains. This is craters Ptolemy, Alphonsus, and Arizel. They're best seen when the moon is about a week old, so a few days ago. But what you can see here is this little dark hair clip running through here. Now, I took a picture of it a few nights ago, and that was really prominent. That's a famous Great Wall, Rupus Rector, which, although it looks quite a distinctive feature when the moon is a week old, it's only a very narrow escarpment, probably only about 50 meters high, but enough to cast a very prominent shadow. So let's go right on the limb of the moon now. Probably increase the exposure. So what we've got here, this interesting feature here, this is probably the crater Grimaldi just coming into view. This is quite a large crater, and you can see the sunlight just hitting the rim. But in a few hours' time, that will be fully lit up. If we zoom in a bit on that. So here you can see when the moon is just coming, when sunrise is just happening on the moon, you can see all these lovely little rivulets, which are again formed from this large and shrunk. There's quite an extensive little series of rivulets here. Coming into view the next few days, we will probably have the Marias volcanic domes. This is a volcanic region of Mars here, linked by a lot of little lava tubes, where we're likely, when we establish a lunar colony on the moon, that's the area where we're probably likely to live, because we'll inhabit these evacuated lava tubes, and we'll use the moon's surface to protect us from harmful cosmic rays and radiation. So the moon is a funny old place. It's still amazing, really, to think that, you know, we're only going back there in a year or two's time, having visited it over 50 years ago. Do we have any questions on YouTube?
No, nothing, David.
No.
So what I can do, I can zoom in. There we are. There's a zoomed in shot of Copernicus. We cut the down just a few milliseconds. We're actually looking right inside that crater now, and we can see the twin peaks in the mountains. There's a wonderful shot of this crater. Must have been taken in the 1980s by one of the orbiting spacecraft as it flew over the top of it. And I guess that's the sort of view you'd have. Well, you get a clearer view, of course, if you were without our atmospheric disturbance looking at the top of that. Right. So anywhere else you like to go, Dave?
No, David. I think we've lost Saturn now, probably.
Go back to Jupiter or Mars if you want.
Let's go back to Jupiter. See what's happened to the red spot. Has
Okay.
it gone?
What I will do, I will select Jupiter, go to. So the telescope is probably about 50 meters away from where I'm sitting. It's linked to a little device called an ASIR, which is a little computer that rides on the telescope that works out where the telescope is pointing. And what it will do, it will validate the stars it's picking up by the camera. It says it's detected 156 stars. It's trying to plate solve. It says solving failure, we're going to retry once. It's going to try again. Of course, it might be a bit cloudy over there, but we'll see. So we'll give it one more go.
I think I'd be happy with 216 stars.
Right, I'm going to stop that. And what I'm going to do is take. Oh, I've got it. I can see it here.
There it is. Oh, it's looking quite nice. It's like the red spot's gone.
So what I'll do first of all, if I increase the exposure, you'll see where the little moons are. The moon should start to appear.
There they are.
So I think we've got Europa, Io, and Ganymede. I think Callisto, I don't know where Callisto is, but I don't think it's not on there tonight. So they're the moons of Jupiter. What we'll do now is I will reduce the gain. and we'll zoom in. Our region of interest will go, say, to 360. So we've got a little moon there.
Yep. Okay, another one on the other side.
So we've now lost the great red spot. Can't pick up much detail on a video like this until we actually process it.
Hmm.
The dark South Equatorial Belt, North Equatorial Belt, probably some little festoons somewhere in here. So we've got a moon there and a moon there. I don't think we can get it focused much sharper than that.
No.
Right, we can try Mars if you like.
Okay.
I'll put that back to preview. So we've got Mars. I'm just going to center it. So there we have Mars.
Yep, getting some features. You can see the pole, the ice cap.
Mars is still a bit low in the sky, so the seeing conditions isn't too good.
Yeah.
But you've got polar cap there. I reckon this dark feature here might be the Syrtis Major, just departing the limb. Yeah, you can see it's probably imaging through clouds. It goes
Mm.
bright and then darkens.
Mm.
Just do a recording of that. I'd normally use a Barlow lens on Mars at the moment to get the image scale a bit bigger.
Yeah.
Right then, Dave. Well,
Call it a day.
call it a day then.
Yep.
Thanks everybody for coming along, and sorry we couldn't open up the NLO this evening, but it was just too hazardous.
Yeah, the car park was a nightmare.
We put on some sort of show.
Yeah. Okay.
Right. Good night, all.
Good night, all. Good night, Alan.